So the next step is to connect our quartz crystal microbalance to a USB port. So now we have to select the microcontroller that we are using. In this case, we are going to select the Tec-CEM. It is important to mention that the measurements can also be made with an Arduino, but in this case, as we are using a 10 MHz quartz crystal from Open QCM, it is very important to use the Tec-CEM because it allows us to make the frequency counter for that magnitude. The Arduino has a limitation that is approximately 5 or 6 MHz. So here we are going to select the Tec-CEM. In this case it's okay, 4.1, and the COM serial it is the 11. So let's upload the document. After a few seconds we have this is the Tec-CEM Arduino. In this case it allows us to manage the Tec-CEM with the Arduino IDE. So we go again to the software, and as we can't select the COM11, we're going to refresh. So here we have, and let's connect it. It is important to mention that these indicators tell us if we are doing correctly the process. For example, if I jump one step, let's set up this, it's going to show like a kind of error. So you have to go in order, and if you have any questions about the process, about each step, you can select the info icon. So let's select our 10 MHz and let's initiate the communication. And as it can be observed, it is at 10 MHz. This means that it is properly connected. In a few seconds I'm going to talk about the calibration tool that we implemented in the software. So let's select the delta time and the total time of the measurements. In this case I want a delta time of 0.10 seconds in order to have more data and to see a better behavior. So we set up this, and here is what I was talking about, is that sometimes the quartz crystal has a little bit more or a little bit less of the frequency that they told. So you have to calibrate it. In this case, this is what we want to achieve, exactly this. So at this zone we can work, and because we already obtained the natural frequency of the quartz crystal, so it is in resonance.